Good evening, children.
Good evening, ma'am.
Good evening, ma'am.
Good evening.
Good evening, ma'am.
Good evening.
Ma'am, completed the notes that you gave.
Yeah, yes. We finished this one, right?
Ma'am,
Yes.
completed.
Yes, ma'am.
Yeah, we finished this one. Okay.
Ma'am, this
So we
also.
No, we haven't finished this. I asked you to take screenshots and work it at home, but I have not explained it. Yeah. So here we have a right triangle PQR, a right triangle PQR, right angled at Q. We are given that PQ measures 10 centimeters, PR measures 26 centimeters. With this information, we need to find the length of the side QR. We need to find the length of the side QR, so that is this side, and also find the area of triangle PQR. Find the area of the triangle PQR. So how do we find the side QR? Using Pythagoras theorem. Because it's a right triangle, you can find the length of QR using Pythagoras theorem. So see here, in right triangle PQR, by Pythagoras theorem. So how do you express Pythagoras theorem? The side opposite of the right angle is the hypotenuse. Angle Q is equal to 90 degrees. So this is the right angle. So the side opposite of the right angle is the hypotenuse. So PR is the hypotenuse. So PR square is equal to PQ square plus QR square. The square on the hypotenuse PR square is equal to the sum of the squares of the other two sides is equal to PQ square plus QR square. That's what you see here. Square the hypotenuse and write it separately. Square the hypotenuse and write it separately is equal to, on the other side, write the sum of the squares of the other two sides. So this is the result by Pythagoras theorem. Now substitute the values you have. You know that PQ is 10 centimeters. PQ is 10. QR we do not know. So QR square is equal to PR square, 26 square. PQ is 10. So 10 square. PR is 26 square. Now 10 square is 100 plus QR square is equal to 26 square. So 26 into 26 is 676. So QR square is equal to, when you transpose 100, when you bring 100 to the other side, minus 100. So QR square is equal to 576. QR is equal to the square root of 576. QR is equal to 24. The square root of 576. You can use a long division method to find. How do you find the square root of 576? Use a long division method. If you know it, you can write it straight away, 24, or you can do this in the rough column. 2 2s are 4, 2 2s are 4, 1 is a remainder. The next pair, 7 6 makes a pair, 5 stands alone. So the next pair, 7 6 comes down, double the quotient. And since you need a 6 here, 4 4s are, or 6 6 are 36. I'm trying 4. So 4 4s are 16, 1 carry over, 176. So the square root is 24. So find the square root of this number using the long division method in the rough column. Or you can show it as a part of your main work also, nothing wrong with that. So now we found the length of QR. Now children, tell me, yeah, now you can see here this triangle ABC is a right triangle. This triangle ABC is a right triangle, right angled at A. Now write the result using Pythagoras theorem. What will be the result using Pythagoras theorem?
Shall I tell?
Yes, Nandana.
Ma'am, AB square plus BC square is equal to CA square.
CA squared. Okay, this is by Nandana. Okay, Swati, yes. I don't want any explanation. I just want the result. What is it? What will be the result by Pythagoras theorem?
AB square plus AC square equals CB square.
Is equal to CB square is by Swati. Okay, Bhavishya.
AB square plus CB square, BC square, ma'am, is equal to CA square, ma'am.
Okay, Bhavishya. Then Harshita.
Ma'am, I think it is AC square plus AB square equals to BC square, ma'am.
AB square plus AC square is equal to BC square. Okay. Is Mritika there? No. All right. So this is by Harshita. Yes, Harshita, can you explain this? Why you feel it is AB square plus AC square is equal to BC square?
Ma'am, because the base and the opposites, when we add the base and the opposite square, it is equal to the hypotenuse square, ma'am. Hypotenuse square is the longest side, ma'am. According to me, I feel like BC square is the longest side, ma'am. So I thought AC square, sorry, ma'am, AB square plus AC square equals to BC square, ma'am.
Correct. So Swati and sorry, Bhavishya and Nandana, you need to understand that. Harshita, you must write the square on the hypotenuse separately on one side. So you can write it like this. You can write which is the hypotenuse. This is the right angle. Bhavishya and Swati, this is the sorry, Bhavishya and Nandana, this is the right angle. So the side, the side opposite of the right angle is the hypotenuse. BC is the hypotenuse. This is the right angle. Opposite of the right angle is the hypotenuse. BC is the hypotenuse. You must square it in, it should be alone in the LHS or RHS. See, you can write like this, BC square is equal to, square the hypotenuse and write it separately on one side, either in the LHS or in the RHS. So BC square is equal to the remaining two sides, AB and AC, AB square plus AC square. Or you can write AC square plus AB square. BC square is equal to AC square plus AB square. This is also correct. Or what you can write it, since this is the hypotenuse, the remaining two sides, AC square plus AB square. This is the hypotenuse. So AC square plus AB square is equal to the square on the hypotenuse, BC square. The square on the hypotenuse should be written separately, should stands alone in the LHS or RHS.
Yes,
Got it?
Yes, ma'am, understood.
Yeah.
Yes, ma'am.
Okay. So here, why did we write, PR square? See, you can see here, PR square stands alone in the RHS. That's the hypotenuse.
PR square is the
PR is the hypotenuse. Angle Q is 90 degrees. So this is the hypotenuse. So PR square, you can see it. It stands alone in the RHS. These are the remaining two sides. PQ and QR. PQ and QR. Okay, so this is the result by Pythagoras theorem. You'll have to substitute the values. So substitute the values like this. Square them. Then take this to the other side. Transpose. So you get QR square is 576. QR is equal to the square root of 576, which is 24. Now we found QR. We answered the first part of the question. Find QR. Then the area of triangle PQR. So we say the area of a right triangle is half product of legs. And in a right triangle, this is called the hypotenuse. The remaining two sides are called the legs. The remaining two sides are called the legs. This is the hypotenuse. PQ is a leg of the right triangle PQR. QR is also a leg. QR is also a leg. PQ and QR are called the legs of the right triangle PQR. See, PR is the hypotenuse. The remaining two sides are called the legs. The remaining two sides are called legs. So area of triangle, this is a right triangle. So area of this right triangle PQR is equal to half product of legs. So half into legs are PQ and QR. PQ and QR. PQ and QR. So half into PQ is 10 centimeters. So 10. And QR we found here 24. 24. So 2 ones are 2 fives are 24 into 5 is 120 centimeters square. Got that?
Yes, ma'am.
Okay. How many of you finished writing this in your notebook? Finished, Nandana? What about Bhavishya, Harshita, and Swati? Not
Yes,
written?
ma'am.
Yes, ma'am. Done, ma'am.
Done, ma'am.
Okay. Swati, you have to complete, huh? Okay. The next one. Find the smallest square number exactly divisible by 12, 15, and 24. Now, in our junior classes, we have learned the smallest number. We didn't learn this. We have learned how to find the smallest number exactly divisible by 12, 15, and 24. That's the LCM. That's the LCM. If you remove this word square, find the smallest number exactly divisible by 12, 15, and 24. So if this question was asked in 4th standard, we'll find the LCM. We'll find the LCM of 12, 15, and 24. And the LCM of these numbers is the smallest number that is exactly divisible by 12, 15, and 24. You will have to now find the smallest square number. So you must find the LCM and then do some modification with the LCM. Because the smallest number is the LCM of these three numbers. So to find the smallest square number, first find the LCM and then we'll do some modifications with the LCM. See here. So you know how to find the LCM, children. So go on till you get 1, 1, 1 like this. Now, when you take 2 here, all the numbers need not be divisible by 2. Now 15 is not divisible by 2. So 2 6 are 12. Write 15 as it is because it's not divisible by 2. Then 2 12s are 24. Then 2 again, 2 3s are 6, 15 is not divisible by 2. So you write it as it is and 2 6 are 12. Again take 2 because 6 is divisible by 2. 6 is divisible by 2. At least one of the numbers should be divisible. If none of them is divisible, then you should not take that prime number.
I have a doubt in this, ma'am.
Yeah.
Ma'am, we can directly write 3, no, ma'am, because 6 is also divisible by 3.
Yeah, you will get the same numbers. I always start with the least prime number. So I always start with 2, then I try 3, then I'll try 5, then 7, then 11. I go in the order always. Yes, you can take 3 straight away. You will get the same numbers. You can take 3 straight away. Okay. So then again, so when you choose the prime number, at least one of the numbers should be divisible. Now, when you take 2, 6 is divisible by 2. At least one of the numbers should be divisible by 2. So since 6 is divisible by 2, I take 2 again. So 2 3s are 2, right? 3 is not divisible. So write 3 as it is, 15 as it is, and 2 3s are 6. Now 3, 15, and 3. None of them is divisible by 2. Now you cannot write 2. 3, 15, 3. None of them is divisible by 2. Then you cannot write 2. 3. 3 ones are 5s are 1s are 5 1 1 1.
Ma'am,
Any doubt here, children?
ma'am, under 6 you have done that 3 2s are, ma'am, you have wrote that 3 3s are 6, ma'am. In LCM.
2 3s are 6. Yes.
Ma'am, under that 6 you have wrote like 3, ma'am.
Yeah, 2 3s are 6, right?
No, ma'am, she's telling about the second step.
When you divide it by 3, you get 2, no, ma'am, and you have written it as 3.
Right, children. No.
Ma'am, divisible by 12, 15, 24. On that
So
you
I'll
wrote
come from the beginning. Is this correct?
Yes, ma'am.
Yes, ma'am.
All these numbers are correct?
Yes, ma'am.
Yes,
Okay, here.
Ma'am, 3 is 2, no, ma'am.
2, write 3 as it is because 3 is not divisible by 2.
Ma'am, no, ma'am, under 6, ma'am.
Under 6, yeah, 2 3s are 6.
Ma'am,
2
it's
3s.
6 divided by 2 is 3.
My God, where are we? No, children, this step you're saying, right?
Yes.
Okay, see, 3 is not divisible by 2, so I wrote 3 as it is. Is this correct?
Yes, ma'am, it is correct.
Okay, then 15 is not divisible by 2, so I write 15 as it is, correct?
Yes, ma'am. Yes,
Then 6 divided by 2 is 3, so I write 3.
I was confused, ma'am, because we thought that 6 divided by 3 is 2, ma'am. So you have written 3 there.
Ma'am, I think she's asking about that 2 square, 3 square, 5 square. Ma'am.
Here,
Yes, ma'am. In that, why you added double another 3?
Bhavishya, please, Bhavishya,
Ma'am,
who asked me that doubt?
ma'am, I asked her, ma'am.
Yes, Bhavishya, where this step, huh?
Yes, ma'am.
Do you feel I'm still wrong?
No, ma'am, I thought that we have divided by 3, ma'am.
Oh, no. 2. So 3 is not divisible by 2. So we write 3 as it is. 15 also as it is because it's not divisible by 2. And 6 divided by 2 is 3. Okay. So the LCM of 12, 15 and 24 is 2 square into 2 into 3 into 5. So this is the LCM of 12, 15 and 24. Now you see that these primes 2, 3 and 5, they don't occur in pairs. Now all of them should occur, every prime factor should occur in pairs. Only then it will be the smallest square number. When you find the product of these numbers, that's the smallest number. But we need the smallest square number. If it should be a square number, all the prime factors must occur in pairs. So you need to multiply this with 2, 3 and 5 so that it becomes 2 square, 3 square and 5 square. So the required smallest square number, the required smallest square number exactly divisible by these numbers is equal to, write these numbers as it is, write all this as it is, 2 square, see here, 2 square, 2, 3, 5, 2 square, 2, 3, 5. Now you need another 2, so another 2, another 3 and another 5, 3 and 5. So you need to multiply the LCM. You need to multiply the LCM with a 2, 3 and 5. This is the LCM. This is the LCM. This is already in, this already occurs in pairs. So now this, we need another 2, we need another 3 and another 5. So then it becomes 2 square, then these two 2s, 2 square, these two 3s, 3 square, and these two 5s, 5 square. Now find the product of these numbers. You'll get 3600. So 3600 is the smallest square number exactly divisible by these three numbers. You must first find the LCM. LCM will be the smallest number. To find the smallest square number, take up the LCM. This is the LCM. Observe the primes that do not occur in pairs. So these are the primes that don't occur in pairs. So introduce one more 2, one more 3, and one more 5. So that they become 2 square, 3 square, and 5 square. And find the product of these numbers, 3600. So that is the required number. Got it, children?
Yes, ma'am, understood.
Yeah.
Yes, ma'am, understood.
So the LCM is the smallest number. Then when you multiply like this, you get the smallest square number. Because if it should be a square number, every prime should occur in pairs. All right, children. So Sure, all of you finished this? Meaning except Swati, the others have completed. Bhavishya, Harshita, Nandana?
Yes, ma'am.
Yes, ma'am, I completed.
Sure, children? Okay.
Yes, ma'am.
All right. Yeah. So since you have Saturday, Sunday, children, take a screenshot now, complete it and share the pictures with me on WhatsApp, all of you. All right? All of you take pictures of whatever we understand today, complete it later, and by tomorrow evening, you must share the pictures of your working on WhatsApp with me. Now here, find the square root of 81 by the repeated subtraction method. Find the square root of 81 by the repeated subtraction method. We know how to find the square root of 81 by prime factorization method, long division method. We know how to find the square root of 81 by prime factorization method. We also know by the long division method. Now this is by the repeated subtraction method. By the repeated subtraction method. So take up 81. See, you can see here 1, 3, 5, 7, 9, 11, 13, 15, 17. These are odd numbers. These are odd numbers, consecutive odd numbers starting from 1. You can see that these are odd numbers 1, 3, 5, 7, 9, 11, 13, 15, 17. These are odd numbers, consecutive odd numbers starting from 1. So you can understand from what you see on your screen. 81, take up the number minus 1, minus the first odd number, gives you 80. Now write the answer 80 and subtract or take away the second odd number, minus 3, 77. Write 77 minus 5, 72. 72 minus 7, 65. Then 65 minus 9, 56. Go on like that till you get 0. You will get 0. You will get 0. At a point, you will get 0 as the answer. So how many steps? 1, 2, 3, 4, 5, 6, 7, 8, 9 steps. It's taken us 9 steps, or we've used the first 9 odd numbers to get the result as 0. To get the result as 0. So the square root of 81 is 9. So the square root of 81 is 9. Now you can just try it with 16. Now see here, 16, supposing 16. We know the square root of 16 is 4. So 16 minus 1, 15. Then 15 minus what, children? 15 minus?
3, ma'am.
3. What is the result?
12, ma'am.
12. Then 12
12
minus?
minus 5.
5. What is it?
7, ma'am.
7.
7.
Then
7 minus 11. 11.
7. Not prime numbers, okay? Odd numbers. 1, 3, 5, 7. Next one is 7. Yes or no? 1,
Yes,
3,
Yes.
5, 7. 7 minus 7, 0.
0.
So we've used 1, 2, 3, 4 steps. 4 steps. So the square root of 16 is 4.
4.
And can all the numbers be, we can use this method for
Yeah,
all
yeah,
the
meaning all perfect squares. Yes. No, but this method you should use only if they ask you to use this method. For larger numbers, it becomes very tedious, no? So they'll give you only small numbers.
Yes, ma'am.
Yeah. For very large numbers, it's very tedious to find the square root using this method. So mostly if you have to find the square root using the repeated subtraction method, the number given will be very small. All right, children? Simple
Yes.
method, right?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Take a screenshot.
Took, ma'am.
All right. Now recall, children, what are the members of a Pythagorean triplet?
Ma'am, shall I say?
Yes.
Ma'am, 2m the whole square.
Not whole square. 2m.
Ma'am, plus m square minus 1.
No. Tell me again clearly, Swati.
Ma'am, 2m.
Just 2m, Swati.
That's what I said, 2m the whole square.
Ma'am,
Hey,
shall
you
I
said the
tell
whole
ma'am?
square.
Yes, ma'am.
2m.
At the end we add the squares, no, ma'am.
Ma'am, shall I tell ma'am?
No, I don't want to, misinterpret what Swati is saying. Swati, is it 2m the whole square?
Yes, ma'am. Ma'am, I said
Okay.
that only. I wrote it
Okay.
plainly.
Yeah, then next.
Ma'am, m square minus 1 the whole square.
Okay.
Ma'am, and then m square plus 1 the whole square.
Okay, fine. If you have learned it like this in school, fine. So the members of a Pythagorean triplet are 2m, m square minus 1 and m square plus 1. Okay. This is when you write it as an equation, then we write 2m the whole square plus m square minus 1 the whole square is equal to m square plus 1 the whole square. You follow what your teachers told you. So you have to say this is it when you're asked to, tell the Pythagorean triplet.
Yes, ma'am. Ma'am, I wrote like what you did, ma'am, but my sir added 2 in all the members.
Okay, fine. All right. Other schools?
Ma'am, they haven't.
Ma'am, like,
Ma'am, they taught the same.
ma'am,
Whole
they taught
square,
the
huh?
same, ma'am.
So same meaning?
No, ma'am, no, without the whole square, ma'am.
Without the square. Okay.
Without.
We'll follow what our school teacher says. So you do that modification, Swati, or anybody else, so we will not, learn any concept incorrectly here. So your teacher is asking you to present it in a different way. Please do that. Please follow what your school teacher says. Okay. So write a Pythagorean triplet whose smallest member is 20. Write a Pythagorean triplet whose smallest member is 20. So now these are the members of a Pythagorean triplet: 2m, m square minus 1, and m square plus 1. And 2m is the smallest member of a Pythagorean triplet. See, they've given you should write a Pythagorean triplet. You must write a Pythagorean triplet, but the condition is the smallest member in that should be 20. That's a condition. You write a Pythagorean triplet, and the smallest member of that triplet should be 20. You understand the condition?
Yes, ma'am.
Yeah. We must write a Pythagorean triplet in which the smallest member is 20. That means 2m should be 20. 2m should be 20. Because 2m is the smallest member. So that means they want 2m to be 20. So from this you get the value of m. M is equal to 20 by 2. M is equal to 10. So we got the value of m. Now, which is the other member? M square minus 1. So 10 square minus 1. 100 minus 1, 99. And the other member, m square plus 1. 10 square. M is 10. M is 10. So m square meaning 10 square plus 1. So 100 plus 1, 101. Children, there's somebody at the door. I'll just answer the door and come back. Please go through the slide. Yeah. Children, do we understand this? So since it's given the smallest member should be 20. That means 2m is equal to 20 because the smallest member of a Pythagorean triplet is 2m. So 2m is equal to 20. M is equal to 10. Now find m square minus 1. Find m square plus 1. See, the value of m is 10. So m square meaning m is 10. So 10 square minus 1 and 10 square plus 1. So the members of the Pythagorean triplet are 2m, m square minus 1 and m square plus 1. So 20. 2m is 20. Don't write 10. 2m. 2m is 20. Then m square minus 1 is 99. M square plus 1 is 101. So 20, 99 and 101 are the members of the Pythagorean triplet, in which the smallest member is 20. In which the smallest member is 20. Correct?
Yes, ma'am.
Okay. Take a picture, children. Done?
Yes, ma'am.
Okay. Now here, write a Pythagorean triplet, one of whose members is 15. One of whose members is 15. That is, any one member should be 15. Any one member should be 15. So you don't know which member is 15. So you equate it to 2m. If suppose 2m is 15. See, one of the members of the three members, one of it should be 15. Anybody can be 15. In the earlier question, there was a condition. The smallest member should be 20. So you have to equate 20 to 2m. Because the smallest member is 2m. But here there is no condition like that. There is no condition like that here. Any one member should be 15. So when you equate 15 to 2m, you get m is equal to 15 by 2. But it's important that you get m as a natural number. You must get m as a natural number. Natural number, like counting numbers. 1, 2, 3, 4, 5, 6, 7, 8, like that. The value of m should be a natural number. 15 by 2 is not a natural number. It's 7.5 and it's not a natural number, or it's 7.5, it's not a natural number. So that means 2m is not 15. Okay, let's try m square minus 1. What if this one, see, this is a member. Please understand why we are equating. One member should be 15. So 2m is a member, right? 2m is a member. So supposing 2m is 15, this member is 15. This member is 15. I'm trying if this member can be 15. But since I'm not getting a natural number for m, it cannot be 15. 2m cannot be 15. Am I clear, children?
Yes, ma'am.
Okay. So now I'll check with the other members. If the other members can be 15. So I'm checking if this member m square minus 1. M square minus 1 is a member. Is a member of the Pythagorean triplet. M square minus 1 is a member of the Pythagorean triplet. So let us check if this member can be equal to 15. If this member can be equal to 15. So when we work this, m square is equal to 15 plus 1, correct? Minus 1 comes to the other side as plus 1. So m square is equal to 16, m is equal to 4. Square root of 16, m is equal to 4. And 4 is a natural number. So m is equal to 4. You can also equate m square plus 1 to 15 and check. Supposing m square, supposing this member m square plus 1 is 15. Then you get m square is equal to 15 minus 1. M square is equal to 14. M is equal to square root of 14. Again, not a natural number. Do we understand, children? So that's what it is. So we equate it to 15. It's not, m is not a natural number. So this is not possible. Then supposing you equate it to m square plus 1. You get m is square root of 14. Again, m is not a natural number. So this also is not possible. Equating it to 15. I'm sorry, equating m square minus 1 to 15. We tried with 2m, not possible. We tried with m square plus 1, not possible, because in both the cases, we are not getting m as a natural number. Now, m square minus 1 is 15. m square is 16, m is equal to square root of 16m is 4. So that means 2m, the member 2m will be 2 into 4, 8. M is equal to 4. So let's find the members now. M is 4. We have to find the members now. So the smallest member 2m, 2 into 4, 8. Then the other member m square minus 1. M is 4, 4 square minus 1. 16 minus 1, 15. So see here, one of whose members is 15. So we got 15 here. That's what is here also. M square minus 1 is equal to 15. 15. Then m square plus 1. 4 square plus 1. M is 4 children, 4. So 4 square plus 1, 17. So 8, 15 and 17 is the required Pythagorean triplet in which one member, one of the three members is 15. One of the three members is 15. Is it clear, children?
Yes, ma'am.
Yeah,
Yes,
please
ma'am.
take a picture.
Ma'am, so we are substituting the value for m in all the members.
All the members. Once you get the value of m, then we know that the members are 2m, m square minus 1 and m square plus 1. Once you get the value of m is equal to 4, substitute 2m, 2 into 4, 8. Okay, m square. So that m is 4. 4 square minus 1. 16 minus 1, 15. M square plus 1. M is 4. 4 square plus 1. 16 plus 1, 17. Am I clear, Swati?
Yes, ma'am. Ma'am, what if the number is 9, ma'am?
1 second, I'm just getting a call. I'm sorry. Yeah, children. Yes, Swati?
Ma'am, what if they give one of the numbers is 9, ma'am?
Now, 1 second. I'm again getting the call. I'm sorry. Yes, Swati. If one of the members is 9,
Yes, ma'am.
yeah, equate everything to equate 2m, m square minus 1, m square plus 1 to 9. Check if you're getting a natural number for n, m.
Ma'am, I'm getting 10 and 9 if I, 10 and 8, ma'am.
So you're not getting a natural number in any case, right?
Yes, ma'am.
Can you say any Pythagorean triplet in which one of the members is 9?
Ma'am, if they can't be expressed, so it should not be, one member can't be 9.
Yeah, correct. You cannot, if you're not, if on you should equate 9 to 2m, m square minus 1 and m square plus 1. If you're not getting a natural number anywhere, that means you cannot make a Pythagorean triplet in which one of the members is 9.
Yes, ma'am.
All right. Children, did you take a screenshot?
Yes, ma'am.
All right. This is the next one. Find the cost of erecting a fence. Find the cost of erecting a fence around a square field whose area is 16 hectares. If the cost of fencing is rupees 30 per meter square. I can see Swati and Nandana. Bhavishya and Harshita, are you there?
Yes, ma'am.
Okay, very good. Yeah. Now, children, What is the area given to be? It's a square field. What is the area given to be? Area is equal to 16 hectares. How do you convert hectares to meter square? 1 hectare is equal to 10,000 meters square. All right. 1 hectare. 1 hectare. Like how we say 1 kilometer is 1,000 meters. This is for length. A length of 1 kilometer is equal to 1,000 meters. Or a distance of 1 kilometer is equal to 1,000 meters. Similarly, this is length here. 1 kilometer is the distance, maybe may represent distance between two places. 1 kilometer is equal to 1,000 meters. Now hectare is a unit for area. Hectare is a unit for area. 1 hectare. Hectare is not a unit of length. Hectare is not a unit of length like kilometer, meter, centimeter, millimeter, decimeter, hectometer. Hectare is not a unit of length. It is a unit of area. It's two-dimensional. Millimeter, centimeter, decimeter, meter, decameter, hectometer, kilometer. These are units for length. 1 millimeter, 1 centimeter, 1 decimeter. Unit of length. Hectare is not a unit of length. Hectare is a unit of area. 1 hectare means an area of 10,000 meters square. 1 hectare means an area of 10,000 meters square. So that means if that means supposing there's a square field, then each side of the field should measure 100 meters. 100 meters. Just to imagine 100 meters running race. You know the distance, right? 100 meters running race. You can kind of gauge the distance. 100-meter running race. So that distance, that is 100 meters. So that 100 meters. So if you have a square piece of land, if you have a square piece of land of side 100 meters, and how much is 100 meters? That distance, you know, like as I told you, in a running race, that distance of 100 meters you can gauge. So if you have a square field of side 100 meters, then the area of that field will be 10,000 meters square, and that is 1 hectare, and that is 1 hectare. So if you say I have a hectare of land, if you say I have 1 hectare of land, that means the area of your land is 10,000 meters square. It need not be a square piece of land. It need not be a square piece of land. It can be, see, it can be rectangular, whatever. If it's rectangular, when you multiply the length and breadth, you will get 10,000. When you multiply the length and breadth, if your piece of land is a square, if your piece of land is a square, then each side will measure 100 meters. Then your area is side into side, side into side, 100 into 100, 100 into 100, 10,000 meters square. 10,000 meters square. Area will be 10,000 meters square. Because side into side, 100 into 100, 10,000 meters square. So that means you have 1 hectare of land. 1 hectare of land. But 1 hectare of land need not be a square always. It can be even rectangular. Okay, maybe it can be triangular, whatever shape. The area should be 10,000 meters square. Then it is 1 hectare. So if it's a rectangular piece of land, when you multiply the length and breadth, you must get the answer as 10,000. When you multiply the length and breadth, because L into B is area. L into B is area. So when you multiply the length and the breadth of the rectangular plot, you must get the answer as 10,000 meters square. Then the area of that land is 1 hectare.
And so in that case, L will be 1,000 and B will be 10.
Yeah. No, it need not be that. No, it can be anything. Can it be 500 and what can it be here? 20? $520?
Yes, ma'am.
Yeah. Okay. So this is what it is. 1 hectare. 1 hectare is an area of 10,000 meters square, not centimeter square, meter square. So 1 hectare is 10,000 meters square. 16 hectares will be 16 hectares.
And
Will be
1,60,000.
yeah 16 into 10,000 meters square. 16 into 10,000 meters square. 16 into 10,000 meters square. So let me show you the answer slide directly. So see here, children, area of the square park is 16 hectares. That means 16 into 10,000 meters square or 1,60,000 meters square. I hope you all understood this. Correct?
Ma'am, I have a
Yes.
ma'am, how many rows does 1 hectare has, ma'am?
Swati, please come again.
Ma'am, how many zeros does 1 hectare has, ma'am?
How many zeros a hectare has?
Yes, ma'am.
Ma'am, 4 zeros.
I told you hectare is a unit of area, not length. Like kilometers, 1 kilometer is 1,000 meters. It has 3 zeros. Hectare is a unit of area. It's not a unit of length. Okay, so 1 hectare is 10,000 meters square. So the area of the square park is 16 hectares. It's given here. Area 16 hectares. So convert the area in hectares to meters square. So you'll have to multiply by 10,000 because 1 hectare is 10,000 meters square. So 16 hectares will be 16 into 10,000. 16 into 10,000. 1,60,000 meters square. So this is the area of the square park in meters square. This is the area of the square park in hectares. And this is the area of the square park in meters square. Now, how do we find the side of the square park? So we have seen earlier that side of the square park will be the square root of area. The square root of area. The square root of area. The square root of 1,60,000. So how do you find out the square root of this number without actually calculating, meaning without actually performing the long division or the prime factorization method? See here, 16, 1, 2, 3, 4. The square root of 16 is 4. And the number has 4 zeros. So the square root will have 2 zeros. 1, 6, 1, 2, 3, 4. The square root of this number will be, the square root of 16 is 4. And this number has 4 zeros. Its square root will have half the number of zeros. So 2 zeros. Its square root will have half the number of zeros. 4 means 2 here. You check what is 400 into 400. 400 into 400. 4 4s are 16. 1, 2, 3, 4. 1, 2, 3, 4.
Yes.
Yeah. So the square root of, so if you're given a number like this, 9,000, you can directly say that 9,000 is not a perfect square because the square root of 9 is 3. You don't even have to find the square root of 9. Supposing you take 8,000. 8,000. Now 8,000 is not a perfect square because it ends with odd number of zeros. Numbers ending with 1 0. Numbers ending with 1 0.
Numbers, odd numbers,
Yeah.
odd number of zeros will not be perfect square.
Will not be a perfect square. Perfect.
Okay.
Numbers ending with odd number of zeros will not be a perfect square. So 1 0, 3 zeros, 5 zeros.
Only even numbers happen.
Yeah. But all numbers that have even number of zeros need not be a perfect square. All numbers that have even number of zeros need not be a perfect square. Like 100 is a perfect square, but 200 is not a perfect square. It has even number of zeros, 2 zeros, but it's not a perfect square. 400 is a perfect square. 900 is a perfect square, but 800 is not a perfect square. It has even number of zeros, but it's not a perfect square. Okay, so first convert the area in hectares to meter square. Then the side of the square park is square root of area. So square root of 1,60,000, which is 400. Now, once you find the side, it's easy to find the perimeter. Perimeter is 4 into side. 4 into 400, 1,600 meters. So now you found the perimeter. Fencing is done. Fencing is done along the perimeter, right? Fencing. Where will you put up the fence? Along the perimeter. Along the perimeter. So you should, to find the cost of fencing, you must find the perimeter. See, for square, you can find two things, area and perimeter. For a square, you can find two things, area and perimeter. Now, it's not area here, it's perimeter, because fencing, where will you put the fence? You will put the fence here along the boundary like this. Here is the fence. Fencing is done here along the boundary. That's nothing but the perimeter. So to find the cost of fencing, you need to find the perimeter. So perimeter of the square park is equal to 4 into side. 4 into side. 4 into side, or 4a. 4 into 400. 1600 meters. Now the cost of fencing is equal to perimeter into rate. Perimeter into rate. What is the rate? For 1 meter, to put a fence to a length of 1 meter, you'll have to pay 30 rupees. So if the length of your fence is 2 meters, you'll have to pay 60 rupees. If the length of your fence is 3 meters, then you'll have to pay 90 rupees. But what is the length of your fence? 1600 meters. This is the length of your fence. So then you should pay him 1600 into 30 rupees. Into 30. 48,000 you'll have to spend for fencing. For 1 meter, rupees 30 per meter. That means 1 meter of fencing will cost you rupees 30. If you put up fence to a length of 1 meter, you'll have to pay the person 30 rupees. 2 meters, 60 rupees. 3 meters, 90 rupees. Then for 1600 meters, 1600 into 30 rupees. Rupees 48,000. So first, convert the area in hectares to meter square by multiplying by 10,000. That's the first step. Then you got the area in meter square. The square root of area will give you the side of the square park in meters. So 400 meters. Now you know the side. Next, find the perimeter. 4 into side. So you got the perimeter and find the cost. Perimeter into rate. Rate per meter, everything. Rate per meter. Is it fine, children?
Yeah, ma'am, fine.
Yeah.
Yes.
Take a picture, all of you.
Book, ma'am.
Took,
All right.
mom.
I'll let you know. Let me just do these two and then come to this. With this, we come to the end of squares and square roots. Yeah. So find the square root of 130. Okay. Find the square root of 7, correct up to 2 decimal places. Find the square root of 7, correct up to 2 decimal places. Yeah. How do we, this is very important, children. May not be, maybe you have not learned it in school now. Very useful for, standards ahead. So don't ignore this. Seven. 7 means 7.000000. I've added 3 pairs of zeros because I have to find the square root up to 2 decimal places. If you have to find the square root of the number up to 2 decimal places, then add 3 pairs of zeros. 3 pairs of zeros. 2 decimal places, 1 extra, 3. 2 plus 1, 3. Add 3 pairs of zeros. What is 7? 7 is 7.000000. You can add how many ever zeros you want. 7 means 7.000. Any number of zeros you can add. So how many zeros you add here? Since we have to find the square root of 7 up to 2 decimal places, 2 plus 1, 3. We'll add 3 pairs of zeros. 3 pairs of zeros. So 7.1 pair, second pair, third pair. 3 pairs of zeros. And you know, after the decimal point, we group in this direction. After the decimal point, we group in this direction. Is this understood?
Yes, ma'am.
Yes, ma'am.
Then the long division is the usual procedure. Long division is the usual procedure. Now, before the decimal point, you have 7. So 7 stands alone. So we start with 2 2s are 4 because 3 3s are 9 is greater than 7. 3 3s are 9 is greater than 7. So 2 2s are 4. Remainder 3. Double the quotient. 4. Correct?
Yes, ma'am.
Now you're going to bring the next pair down. The next pair is a pair of zeros after the decimal point. So you should place a decimal point here. When you're bringing the first pair after the decimal point, place a decimal point in the quotient also. We didn't start with a decimal point because 7 is before the decimal point. So 2 2s are 4, 3 is the remainder. Now you're going to bring a pair of zeros down, and that is the first pair of zeros after the decimal point. So since you're getting the pair of zeros which is after the decimal point, you must place a decimal point in the quotient and then bring the next pair down like this. Is this understood?
Yes, ma'am.
Double
Yes,
the
ma'am.
quotient. Yeah, double the quotient. 2 to the 4. Now it's a usual procedure. Same thing.
Ma'am,
What
we
do you-
can multiply 46 into 6, ma'am.
46. Okay. What is 46 into 6?
Ma'am, 276, ma'am.
6 6 are 36. 3 carry over. 276. Okay. 276.
7 into 7 is 329, ma'am. That is greater than 300.
Sorry?
Ma'am, when we are multiplying 47 into 7, it is greater than 300, ma'am.
What is 47 into 7? 7
Ma'am,
7s are 49. 9. 4 carry over.
329, ma'am.
Yeah, 7 4s are 28. 32. 329. Yeah. What's the remainder here?
Ma'am, 24, ma'am.
24,
24
ma'am.
is a remainder. Now the next pair can come down. The next pair can come down. Double the quotient. Now, how do you double the quotient? Don't see it as 2.6. See it as 26. Don't see the decimal point there. 26 is the number. When you're doubling the quotient, ignore the decimal point. Just take away the decimal point. See, what do you see? 2.6. No, don't see the decimal point. So you see only 26. Double the quotient. So you'll get what? 26 into 2. How
Ma'am,
much?
we can. Ma'am, 52, ma'am.
That's all, children. So whatever you add here, you should add the same thing here. Whatever digit you place here, you must place the same digit here.
Ma'am, we can place 4, ma'am.
4, huh? Okay.
Yes, ma'am. 2096 we are.
What is 524 into 4?
2096, ma'am.
2096. Did you try 525 into 5?
Yes, ma'am. We are getting the answer as 2625, ma'am.
Okay, so what is this? 524 into 4?
Ma'am, 2096.
2096, ma'am.
Okay, 2096. What's the remainder?
304, ma'am.
304.
304. Bring the next pair down. This is the last pair. That's all. Bring the next pair down. Now double the quotient. Whatever. So now in the quotient you see 2.64. Don't see the decimal point. It's only 264 into 2. Double the quotient.
528, ma'am.
528. 528. Whatever digit you place here, you must place the same digit here.
Ma'am, it should be like 5 to 8, 5. I mean, 5 into 5, ma'am.
5
Yes,
into
ma'am.
5. Now we will not exactly get 30,400 because 7 is not a perfect square. So you will not get 0 as a remainder.
Yes, ma'am.
So you should not try to get 30,400 exactly. You will not get. So you will find a number just less than 30,400. And you said it's 5 here.
5, yes, ma'am.
Okay, so let me see if we are right.
Ma'am, 26,425 we are getting, ma'am.
Okay, and the remainder? 425. Okay, what's the remainder?
I'm 3,975.
3,975. Let's see if we are right. Yes, perfect. So this is the procedure to find the square root of an imperfect square up to some number of decimal places. Now we found the square root of 7. What is square root of 7? We got 2 point. See, it goes on forever. The square root of 7, the value of square root of 7 goes on forever. You can keep, adding pairs of zeros, and you can continue the long division. Endlessly it goes. We have stopped with 3 decimal places, 6, 4, 5. You should always find, if you have to find up to 2 decimal places, find up to 3 decimal places and round it to 2. So, so square round off children.
I'm 2.7.
No, round off to 2 decimal places.
I'm 2.65.
Okay. So see, again, there will be, so now if your teacher says 5 and greater than 5, you should increase this, increase it. If your teacher says no, it should be more than 5. More than 5 only, you should increase this, then you write it as 2.64. Round off to 2 decimal places, children, that's all. You should find up to 3 decimal places and round it off to 2 decimal places. Yeah, take a screenshot, children. Take a picture. I told you, you can write it as square root of 7 is equal to, you can just include this step. Take a screenshot with this one, children. Please take a picture with this one. Square root of 7 is equal to 2.645. Correct. Up to 3 decimal places. 3 decimal places, okay? And when you round off, that's what I told you. You can write it as 6.4 or 6.5. Correct to 2 decimal places.
Yes, ma'am. Ma'am, so if they ask
Screenshot.
decimal places, we need to round off. I mean, we need to add 4 pairs of 0.
Yeah. If they ask you to find up to 3 decimal places, you should add 4 pairs of zeros. So then you will get 4 digits after the decimal point. You will get 4 digits after the decimal point. You must round it off to 3 digits.
Yes, ma'am.
Yeah.
Yeah, ma'am, took screenshot.
Yeah, so it's the regular procedure, children, nothing different. Just that when you're bringing the first pair, which is after the decimal point, see, after the decimal point, when you bring the first pair down, you must place the decimal point in the quotient. That's all. You must place the decimal point in the quotient. Other than that, the procedure is the usual procedure.
Yes, ma'am.
Yeah. So here, 135.9 up to 2 decimal places. Now you know that 135.9 can be written as 0.900. You cannot write it as 135 point. You cannot write 9999. That's wrong. It's 135.9. You can add how many ever zeros you want. You cannot add nines. You can add how many ever zeros you want. So 135.9. You need 3 pairs after the decimal point, because up to 2 decimal places. So 3 pairs. So 90 forms 1 pair, 00 second pair, 00 third pair. Do we understand?
Yes, ma'am.
The number is 135.9. You can add any number of zeros because you're not changing the value. You cannot say 999999 like this. That is incorrect. So 135.9 is the number. Add a 0 and that becomes 1 pair. Then 2 zeros, second pair. 2 zeros, third pair. No, you don't have to show this arrow, children. I'm just reminding you that after the decimal point, we group in this direction. We group in this direction. Before the decimal point, we group in this direction. Decimal point. Before the decimal point, in this direction, we group. After the decimal point, we group in this direction. We make pairs in this direction. You can just put a bar. You can just put a bar, but I just remind children the direction. So I, show the arrow. Yeah. Now the rest is the same. The rest is the same. So it's important to write the number correctly. All of you understand this?
Yes,
Why
ma'am.
we have 3 pairs after the decimal point?
Yes, ma'am.
Yes, ma'am.
Because 2 decimal places. All right, children. Yeah, please take a screenshot. You don't have to copy it from here, so you can do it yourself when you're working it in your classwork, meaning your tuition notebook. Then you can check your answer with this.
Ma'am, I was done. Okay, ma'am.
Yeah. So square root of 135.9 is equal to 11.657. Correct to 3 decimal places. Correct to 3 decimal places. 3 dp. So 657 is rounded off to 66. 11.657. So 7 is greater than 5. So take it away and increase this by 1. So 66. Took a screenshot, children?
Took, ma'am.
Took, ma'am.
Yeah. So we have one more question, and with that we come to the end of squares and square roots. So I'll share the videos on cubes and cube roots, children. That's again a very simple chapter. Once you've understood squares and square roots, cubes and cube roots is a very small and will be very simple because you know squares and square roots. So I'll share all the lesson plans. I'll share all the videos because I'm telling you again, it's very easy. So this weekend you have a lot of tasks to complete. I'll share all the videos on cubes and cube roots. Watch all of them and complete your tuition notebook.
Ma'am, can I watch the video after 11th, ma'am?
After 11th?
Yes, ma'am, because I'm having midterm exam, ma'am.
Oh. What about the others?
Ma'am, I'm having worksheet the next week, ma'am, in the coming week.
The coming Monday, is it?
Yes, ma'am, it starts from Monday. No, ma'am, from Tuesday.
What about Harshita and Nandana? I think both of you just finished a test at school, right? Nandana and Harshita, are you there?
Yes, ma'am. Ma'am, we are having our next slip test at 11th.
July 11th, ma'am.
July
July
11th.
11th.
Yes, ma'am, we are going.
Okay, okay, since you have exams at school, Swati and Bhavishya, you can take your time. 1 second, children. Yeah, children, I'm back. So Swati and Bhavishya will not be attending the classes then next week?
Ma'am, I will be attending on Monday and Wednesday only, ma'am.
Okay. All right. So children, here the area of a square field is 22,500 meters square. The area of a square field is 22,500 meters square. So then what is the side? How do you find the side? How do you find the side?
Finding the square root of 22,500.
Yeah. And what is the square root of 22,500? What is the square root of 225?
15, ma'am. So 150.
15. And 2 zeros, 1 0. So 150 meters. Side is 150 meters. What will be the perimeter? What will be the perimeter? Sorry?
4 into 50,
4
ma'am.
into 1.
4 into 150 meters. That is 600 meters is the perimeter.
Yes,
Okay.
ma'am.
Yeah. So a man cycles along its boundary at 6 kilometers per hour. In how much time will he return to the starting point? All right. So see here, given the area, the square root of the area will give us the side of the square field. And since he is cycling along the boundary, you need to find the perimeter. Once I explain the answer fully, you will understand. Since the man cycles along its boundary, he's cycling along the boundary. It's a square field. And where is he cycling? He's cycling along the boundary. So the distance he covers is equal to the perimeter. The distance he covers is equal to the perimeter of the square field. So 4 into side, 4 into 150, 600 meters is the perimeter. This is the distance he covers. This is the distance he covers. Children, we know the formula. Speed is equal to distance by time. Do we know this? Speed is equal to distance by time. And time is equal to distance by speed. Yes or no?
Yes, ma'am.
Speed is equal to distance by time. And what is distance equal to? What is distance equal to?
Time into speed.
Speed into time. Speed into time. Here. See children? Speed is equal to distance by time. Distance is equal to speed into time when you cross multiply. Time is equal to distance by speed. Maybe if you want, you can make a note of it. Speed is equal to distance by time. Time is equal to distance by speed. And distance is equal to speed into time. Please make a note of this. Just in case you have some doubt, please make a note of it. Done, children?
Yes, ma'am.
Okay. So now in how much time we have to find the time taken? That means we need to know the distance and the speed. The speed is given to us 6 kilometers per hour. The speed is given to us. Here, a man cycles along its boundary at 6 kilometers per hour. 6 kilometers per hour itself means speed. From the unit, you can make out the speed. When something is expressed in kilometer per hour or meter per second, it represents speed. Kilometer per hour, meter per second are units of speed. So a man cycles along its boundary at 6 kilometers per hour. That means he's cycling at a speed of 6 kilometers per hour. In how much time will he return to the starting point? So to find the time taken, you need to use this formula, distance by speed. So distance, you have to find the distance. Speed is given. What is the distance? Well, where does he cycle? Along its boundary. That means he completes the perimeter of the field once. He just goes once along the boundary. He just goes once along the boundary. So 4 into side, 4 into 150, 600 meters. So the man cycles along the boundary and he covers a distance of 600 meters. But since the speed is in kilometers per hour, the speed is in kilometer per hour, you should have the distance in kilometers. You must have the distance in kilometers, but the distance here is in meters. The distance here is in meters. In the speed here, the distance is in kilometers, 6 kilometers per hour. It's 6 kilometers. 6 kilometers. So that means the distance should be in kilometers. So how do you convert meters to kilometers? 600 by 1000. When you divide by 1000, you're converting meters to kilometers. So that's nothing but 6 by 10 or 0.6 kilometers. 6 by 10 or 0.6 kilometers. So this is the distance he cycles. So we found the distance he cycles and we know the speed. We know the speed. So now we can find the time taken. Time taken is equal to distance by speed. Distance we found here 0.6 kilometers. So 0.6 by speed 6 by 6. Now to work this, you'll have to shift the decimal point. So you can multiply and divide by 10. You want to shift this decimal point 0.6. You want to shift this decimal point. So multiply and divide by 10. So 0.6 into 10 will give you 6. By 6 into 10, 60. So that's nothing but 1 by 10. So since the speed is in kilometer per hour, time will be in hours. So you'll wonder how you know you should write hours. Why not minutes or seconds? It's hours because the speed is in kilometers per hour. So the answer you get for time will be in hours. Will be in hours. So now we don't understand 1 by 10 hours. We don't understand what is this 1 by 10 hours. So multiply by 60. So see again, whether to multiply or divide, you can remember like this. Minutes, seconds, minutes, hours. Always. Now here it is 60. Here you should use the number 60. When you're converting a bigger unit to a smaller unit, multiply by 60. When you're converting a smaller unit to a larger unit, divide by 60. So when you're going up like this, multiply by 60. When you're coming down, divide by 60. Seconds, minutes, hours. The number is 60. If you're converting downwards, divide by 60. You're converting upwards, multiply by 60. That is if you're converting a larger unit to a smaller unit, like hours. So hour is a larger unit. When you're converting that to a smaller unit, like seconds or minutes, you should multiply. Larger unit to smaller unit, multiply. Smaller unit to a larger unit, divide. And it is 60. The number is 60. So 1 by 10 hours, you want to convert hours to minutes. So hours to minutes like this, you have to go like this. Hours to minutes. Hours to minutes. So you should multiply by 60. Supposing you want to convert hours to seconds, you should multiply by another 60. That is, you should multiply by 3600. For every step, you should increase 60. Hours to minutes is 60 into 60. Hours to seconds is into 60 into 60. Meaning multiply by 62 times into 3600. So it is hours to minutes, so into 60. So you can see gets cancelled 6 minutes. So the time taken to reach the starting point is 6 minutes. Children, go through the slide. I'm just coming back. You all there?
Ma'am,
Bhavishya?
Yes, ma'am.
Bhavishya, are you there? Harshita, are you there?
ma'am,
Harshita, are you there?
Yes, ma'am. Yes, ma'am.
Swati?
ma'am, yes, ma'am, can you hear me?
Ma'am,
Yes.
ma'am, I should take a screenshot.
No, I can't hear you.
Ma'am, can you hear me now?
Yes, Swati?
Ma'am, I
I
wanted,
can hear you, but it's not clear. Yes?
ma'am, I wanted to ask a doubt, ma'am.
Hmm.
Ma'am, can we also say that 1 by 10th of an hour, so we are multiplying it with 60?
That's what it is. Correct. 1/10 of an hour it is. Yes, that's why we're multiplying by 60. Correct.
Ma'am, so we
1
can
by 10.
1 by 10 itself, no, ma'am. Why are we doing it in minutes, ma'am?
No, like when I say 6 minutes is easier to understand. 1/10 of an hour, right? Yeah, no. Now, if you tell somebody that I need 1 by 10, 1/10 of an hour to reach some place, we normally don't talk like that. Correct? We say half an hour. Half an hour we say. We use half an hour, but we don't use 1/6 of an hour, 1/5 of an hour, 1/10 of an hour. So just to make it more clear, see, when there's a difference between saying 1/10 of an hour and saying 6 minutes. So 6 minutes, all of us understand 6 minutes. 1/10 of an hour, you have to calculate. So we do that calculation. So it's easy to understand.
Yes, ma'am. Ma'am, I had a doubt that if we write 1 by 10 of an hour, they will give marks or not, ma'am.
Oh, you should convert it to minutes. Yes, they will give you marks. It's better you convert it to minutes. You should leave it, the answer should be kind of understandable. You must not leave it like this, like where you have to calculate to understand. 1/10 of an hour, even you will calculate, right? If you want to understand 1/10 of an hour, even you will calculate. You'll do it in your mind 1/10 of an hour into 60. Oh, 6 minutes. That calculation, you should present it here.
Yes, ma'am, understood.
So children, we are given I'll just do it once again. We are given the area of the square field, children. We have given the area of the square field. Using the area, the square root of the area will give us the side of the square field. That's the first step. Now the next thing is why we are finding perimeter. Why should you find the perimeter of the square field? Because there is a man who's cycling along the boundary of the square field. If he's going along the boundary, you want to find out what distance he's covered. Okay, there's a man who cycles along the boundary of the square field. So he's doing one round along the boundary of the square field. So what is the distance he has covered? He's covered the distance equal to the perimeter of the square field. The distance he covers will be equal to the perimeter of the square field. So to find the distance he has cycled, we have to find the perimeter. Perimeter of the square field is equal to 4 into side, so 600 meters. Now we convert meters to kilometers. Why? Because we're going to, this is nothing but distance. This perimeter is nothing but distance. This perimeter is nothing but the distance he has cycled. And you're going to find the time taken. That is how long he takes to make one round along the boundary of the square field. What is the time he takes? That is what you'll have to find. And now the speed given is in kilometers per hour. That means you must have the distance in kilometers. The speed given is in kilometers per hour. That means you should have the distance in kilometers. We have the distance in meters here. So we convert it to kilometers. How? By dividing by 1000. 600 by 1000. So 0.6, I showed you that. Zeros gets cancelled. 6 by 10 or 0.6 kilometers. So we found the distance. So this 0.6 kilometers is the distance he has gone along the boundary. Now time is equal to distance by speed. That's the formula. Time is equal to distance by speed. What is the distance he has covered? 0.6 kilometers. This is the distance he has cycled, 0.6 kilometers. So 0.6 by the speed, 6 kilometers per hour. Now to calculate this, you want to move the decimal point. So we multiply by 10 and divide by 10. 0.6 into 10 is 6. 6 into 10 is 60. So 6 by 60, 1 by 10. And since the speed is in kilometer per hour, the time you get will be in hours. 1/10 of an hour. 1/10 of an hour. And when you're converting hours to minutes, you need to multiply by 60. So when you multiply by 60, hours is converted to minutes. Hours is converted to minutes when you multiply by 60. So 1 by 10 into 60 minutes, not hours again, into 60 minutes. So this is nothing but 6 minutes. So the time he takes to reach the starting point, that is to make one round, to go once along the perimeter, he takes 6 minutes. 6 minutes. So this is nothing but the distance covered. Perimeter is nothing but the distance covered. Distance covered by the man. Distance covered by the man. All right, children?
Yes, ma'am.
Yes, ma'am.
All right. So with this, we come to the end of squares and square roots. As I told you, I'll share the videos on cubes and cube roots with you. Please watch and complete your tuition notebook. Now, by tomorrow, I want these notes, children, to be completed in your classwork, whatever screenshots you have taken today. All right? Whatever screenshots you have taken today, please complete all this in your notebook and share your pictures by tomorrow evening. All right? All right, children. Fine, children. Yes.
Ma'am, do you have the recordings of rational number, ma'am?
Yes, I have.
Ma'am, since I have worksheet, I will revise your recordings, ma'am. Can you send it to me?
Yeah, sure. I'll share the playlist with you. Okay.
Yes, ma'am.
Okay, fine. All right, children. Thank you so much. Good night.
Thank you, ma'am.
Thank you.